Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher. Today we are going to discuss one topic from Organic Chemistry class 11 from the chapter GOC. Let me first write down the title. Okay, so today we are going to discuss about the new topic from Organic Chemistry class 11. The title of the just a minute. Yes, it belongs to the chapter General Organic Chemistry, or which is also called as GOC sometimes, or some basic principles of organic chemistry. And the title of the topic is Structural Representation of Organic Compounds. Structural representation of organic compounds. Okay, now first of all I'll tell you about what are the different ways to draw the structure of the organic compound, and then we are going to discuss about some examples, right? Okay, so as far as organic compounds are concerned, organic compounds, for example hydrocarbons, we are going to discuss first of all. So they are made up of, or they contain hydrogen and carbon atom in them, right? So basically how to show the structures of these hydrocarbons by using different structural representation, that we are going to discuss in today's class. Okay, so there are different ways for structural representation. I'll let you know one by one all of them. So first of all, it is divided into two parts. So first is the 2D or two-dimensional structural representation. 2D or two-dimensional structural representation. And next is the three-dimensional or 3D. 3D stands for three-dimensional. Three-dimensional structural representation. Three-dimensional structural representation. Okay, yes, so these are the two main types of the structural representation. Now in two-dimensional structural representation, again there are three ways. First is complete structural representation or complete structural formula. Second one is condensed formula. Second one is condensed formula. And third one is the bond line formula. Bond line formula. Okay, so these are the 2D or two-dimensional structural representation. Now let us see the three-dimensional structural representation. So in that there are again three main types. So first one is called as the wedge and dash representation or wedge and dash formula. I'll first of all list all of them and we are going to discuss them in detail later. Okay, so first in it is the wedge and dash wedge and dash vision dash formula. The next one in this is framework model. What are the meanings of all this we are going to discuss later on. Framework model. After this, the next is ball and stick model. And the last one in this is space filling model. Space filling model. Okay, so these are the different ways to represent the structure of organic compound, structure of hydrocarbon. Okay, yes, so first of all, you guys can do one thing. You guys can just take a screenshot of this page. I'll just remove the video for some time till you take the screenshot, otherwise this portion will not be visible. I hope it is done. Okay, then now after this, in this you can see there are two ways, 2D and 3D. So in case of 3D, we are going to discuss the 3D structural representation some other day. First of all, our focus will be on completing the 2D structural representation one by one, right? So there are three different formulas used in case of 2D structural representation: complete structural formula, condensed formula, and bond line formula. Okay, we will see these formulas one by one, and we are going to see how to convert this formula into each other. Okay, so let us first of all focus on the condensed or the 2D formula, in which the first one is the complete structural formula. Complete structural formula. Okay, now the complete structural formula will give you idea about everything, the atoms, the bonds present in it, everything about it, right? Okay, so we'll do one thing, we'll have some example. So first example for complete structural formula is ethane, right? Okay, now in case of ethane is an alkane. The molecular formula of ethane, the general formula for alkanes is 2CnH2n plus 2. For ethane, n is equal to 2. Okay, therefore formula will be C2H2n plus 2, that is 2 into 2 plus 2 equals to 6, right? Okay, therefore C2H6 is the molecular formula for ethane, right? C2H6 is what? It is the MF, molecular formula. Okay, molecular formula gives you the idea about how many and atoms and how many and what type of atoms are present in any molecule, right? So this is the molecular formula. Now let us see its structural formula, complete structural formula, right? So here you can see there are two carbon atoms. As it is an alkane, both of them are attached to each other by a single bond. Single line stands for single bond. Then always remember, in organic chemistry, the carbon is a tetravalent entity. Carbon is tetravalent species, atom. Therefore tetravalent means what? It should be surrounded by 4 lines always. The 4 lines can be in the form of these many combinations, right? There is no any restriction, that is, but ideally there should be 4 lines surrounding to it. Okay, there is no any restriction. This is also correct, this is correct, this is correct, this is correct. Just the point is we should have 4 lines surrounding to the carbon atom in its structural formula. Okay, 4 lines. 4 lines stands for it is tetravalent. 4 valency is satisfied, right? So if you see in case of ethane, carbon to carbon single bond is present. That means every carbon needs 3 more lines. So that I will attach 1, 2 and 3. 1, 2 and 3. Whatever it is left, satisfy it by using the hydrogen. Okay, satisfy the tetravalency by hydrogen atom like this. So this will be the complete structural formula for ethane, right? Okay, now next example we can see after ethane. Ethane was the first example, and then we are going to see the next example is of butane for an example. Okay, butane, N-butane. Okay, N stands for, this is a straight chain butane, right? There is no branching present in it, right? Molecular formula for butane, N is equal to 4. Okay, butane means but stands for 4 carbon compound. So 4, so 2n plus 2 will be what? It is also an alkane, CnH 2n plus 2. N is equal to 2, therefore 2n plus 2 will be 2 into N is equal to 4, sorry. So 2 into 4 plus 2, that is equal to 10, right? So C4H10 is the molecular formula of butane, right? Now let us see the complete structural formula. It is N-butane, that means there is no branching. All the carbon atoms are in a row, straight chain. So I will draw those carbon atoms 1, 2, 3, 4, right? Now if you observe here, the terminal carbon atom, this and this, okay, terminal carbon atoms are attached only to one line. That means we need to adjust how many lines here? We need to adjust 1, 2 and 3 lines here, 1, 2 and 3 lines here, right? Those lines we will attach to the hydrogen. Valency will be satisfied with hydrogen atom like this. Okay, and then what about middle two atoms? They are already attached to 2 lines. Okay, can you see this? This carbon is attached to 1, 2. This carbon is attached to 1, 2. That means already they are attached to 2 lines. So we need to satisfy only 2 lines, right? Okay, so 1 up, 1 down, 1 up, 1 down. Satisfy it by hydrogen atom, right? Okay, so this is nothing but the complete structural formula for N-butane. Okay, complete structural formula for N-butane. Another example we will see, and that is nothing but the isobutane. Okay, that is nothing but the isobutane. Okay, now for isobutane also the molecular formula is same only, just like butane. For isobutane also molecular formula is same, but iso word stands for there is a branching. What type of branching is present? Always remember, whenever there is iso prefix, okay, prefix iso stands for, iso means the structure contains this kind of skeleton, CH3, CH, CH3, this kind of skeleton at the end. Skeleton at the end. Okay, yes. So let us see for N-butane. So in case of N-butane, 4 carbon atoms are there. What I have told you, at the end there should be this kind of skeleton. So CH3, CH, CH3 should be there. And if you see 3 carbon atoms we have written, only 1 carbon atom is left, right? Okay, so this is what the skeleton is, but this is not the correct complete formula. Complete structural formula will look like this. So first of all I will draw 3 carbon atoms like this, 4th carbon like this, okay, and satisfy the tetravalency by hydrogen for all of them. Okay, total 4 lines should be attached to each and every carbon atom. Okay, tetravalency should be satisfied. Okay, so this is the complete structural formula for isobutane. Okay, I hope you understood all these examples. Take a screenshot of this page one by one. I hope you have taken a screenshot of this part and then take the screenshot of the remaining part. Okay, yes. So now let us see some different structural formula with the same examples. I'll keep different what you can say. Now these examples which I have seen, which I have shown here, these were for alkanes, right? Now I'll show some examples for alkenes and alkynes. Okay, one example we will see. So next example is for alkene. The name of this alkene is propene. Okay, yes. So this is an alkene. So alkene has at least one carbon to carbon double bond. The molecular formula for alkene, general molecular formula is CnH2n, where n is the number of carbon atoms, right? Okay, so prop stands for n is equal to 3, right? There are 3 carbon atoms. Therefore, what will be molecular formula? C3H2n means 3 into 2, 6. So this is nothing but the molecular formula for MF. MF stands for molecular formula of propene, right? Molecular formula of propene. Okay, 3 carbon atoms are there connected to each other in a row, right? So I'll draw those 3 carbon first of all, 1, 2 and 3. As it is an alkene, there should be at least one double bond. Either it can be here or it can be here. As this is a 3 carbon compound, it will not make any difference. It can be anywhere, but it is same molecule. Okay, now let us satisfy the tetravalency of all carbon atoms. So this one, terminal carbon atom always needs 3 hydrogens, remember. Therefore you can see CH3 at the end. Then middle carbon atom, this one is already attached to 2 plus 1, 3 lines. Only one valency needs to be satisfied. So one hydrogen I will attach to it. This carbon atom is attached to 2 lines already. So 2 hydrogen we are going to attach to it. So one like this, another like this. So this is the complete structural formula for propane, right? Now similarly I'll let you know one more example, but it is for alkyne. Okay, so this is for let us say this is for 2-butyne. Okay, this is an alkyne. Alkynes contain molecular formula is CnH2n minus 2, where n is the number of carbon atom. But stands for 4 carbon, so it is 4 and hydrogen will be 2n minus 2, that is 2 into 4 minus 2, that is equal to 6. So C4H6 is the molecular formula for butane, right? Okay, now let us draw the structure. So 4 carbon atoms in a row I will write down, 1, 2, 3 and 4. Here it is 2-butane. What does this 2 stand for here? This 2 stands for the triple bond is attached to, that is triple bond is present at carbon number 3. Okay, for that purpose I need to number it. Okay, I will start numbering from this side, or you can do from this side also, there is no any restriction. Okay, so it is this is carbon number 1, this is carbon number 2, carbon number 3, carbon number 4, right? This is the numbering, okay, numbering of the carbon chain. At the carbon number 2, triple bond is started. So this is your carbon number 2, at which triple bond will be present like this, right? Okay, so then satisfy the tetravalency by attaching hydrogen atoms. Let us start from left hand side. So here we need to attach 3 hydrogens to satisfy the tetravalency. This carbon is already attached to 4 lines, no need to satisfy. Same for this, no need to satisfy. The terminal is attached to only 1 line previously, therefore we need to attach 3 hydrogens to it. So this is the complete structural representation for alkyne, butane. Okay, yes, take a screenshot of this page, try to observe these structures carefully, and let me know if you have any kind of doubt in it. Okay, and if you have any question in mind regarding this, please let me know in the chat box. You are always can write down any doubt in the chat box. Okay, I'll just message hi in the chat box. If you have any doubt in that, please reply in the chat box. Okay, so now these were some examples for bond line, complete structural formula. Now let us see the next type of the formula, and that is nothing but the condensed formula. Okay, so second formula we are going to discuss, and that is called as a condensed formula. Okay, what do I mean by condensed formula? Condensed means we are going to condense the structure. Instead of writing down the complete structure, we are going to make it short and sweet, right? So that is nothing but the condensed formula. So it is really very easy to write down the condensed formula. So for example, I'll tell you some interesting examples instead of the simple one. Okay, yes, so let us see first example. So complete structural formula is given, you have to convert it to condensed formula. I'll write down that part here so that you will understand it. The question is convert the following complete structural formulae into condensed formula. Okay, let us see examples one by one. So first example is this. Just observe the structure very carefully. I am drawing one complete detailed structural formula. Complete structural formulas for some molecules. We have to convert it to the condensed formula. Okay, now let us see how to do that. So condensed formula is nothing but a short but sweet formula. So first of all, this part I'll start with this carbon atom. So this carbon atom is attached to 3 other hydrogen atoms, right? Okay, yes. So instead of writing these many big structure, these like carbon separately, hydrogen separately, instead of writing in this way, I'll do one thing. I'll write it down like this: CH3. That's it. Okay, it stands for this one, right? CH3. That's it. Okay, do you understand? So this, I'll just highlight this carbon atom. So this I have written CH3. Okay, then next is this one. Okay, in case of this carbon, it is attached to 2 hydrogen atom. So without putting any line here like this, without doing that, right, because this is a condensed formula, short but sweet, without keeping any space, I'll write down CH2. Why CH2? These numbers you are going to write down in the subscript. Okay, 2, 3, you are going to write down them in the subscript. CH2, this is the CH2 carbon atom, right? Then next I'll write down about this next carbon atom, which is the CO carbon, right? Okay, now CO carbon, we know CO is nothing but the carbonyl group, this one, right? So instead of writing C double bond O, we'll simply write only C, only O, that's it. Okay, only C and O, that's it. Then next is this carbon atom. We'll write down like this CH2, and then the last carbon atom. This is CH3. Okay, so this is nothing but the condensed formula for the molecule. Okay, you guys can take a screenshot of this structure first of all. Okay, yes, now let us see the next some examples for this conversion of simple formula in detailed formula into condensed formula. Okay, so this is the detailed or complete structural formula. We have to convert it to the condensed formula, right? Now you can see this is a cyclic structure. Even though it is a cyclic structure, we have to write down each and every carbon atom at its position. I'll start with this carbon atom and move in the clockwise direction. So this first one is CH2. Next one is also CH2. Next one is also CH2. Again CH2. CH, CH3. Okay, so this will be the condensed structural formula for this cyclic structure. Okay. Okay, now that's all about the condensed structural formula. Now I'll write down about the third type of formula, and that is the bond line formula. Bond line formula. Okay, in bond line we do not write down the carbon and hydrogen atoms, we only write down about the bonds, right? Every corner is considered as the carbon atom, right? Okay, so let us see some examples. So first of all I'll write down about the propene, okay, or propane, right? Now what is the structure of propane? This is one carbon atom, another carbon, another carbon. Here in case of bond line formula we are going to maintain this kind of coordinates, right? So then this will be 3 hydrogen atoms attached to it, 3 hydrogen atoms attached to this carbon, and 3 hydrogen atoms attached to this carbon as well, right? Okay, now we are going to convert it to the bond line formula. It's very easy. So what you are going to do, wherever carbon is there you are going to add the corner, one corner, second corner, third corner, right? So these 3 corners stands for the carbon atom. That's it. So this will be the bond line formula for propane. Okay, let us see one more example. So here next example, convert the given structure into the bond line formula. NC, CHOH, C triple bond N. This is the question. We are going to convert it to the bond line formula. As I told you, every corner is a carbon. 3 carbon atoms are there, so this is like this. Then attached to OH and CN and CN. CN is the cyanide or nitrile group. Next example we can discuss. Okay, so this is the complete structural formula. We are going to convert it to the bond line formula. As I have told you, for every corner there is a carbon atom. So here there is carbon to carbon triple bond. So always remember, triple bond, that carbon atom, that is here is one carbon, here is another carbon. So next carbon you are going to draw in a straight line. Okay, so this is the first carbon, second carbon, third carbon. Okay, remember. Okay, yes, then next is the CH2 carbon, then again it is the CH3 carbon. On this carbon there is OH group. Okay, for the understanding purpose we can give the numbers also. So this one will be number 1, five, right? So this is to the position number 2, OH group is attached, right? So I'll write down the numberings. This is carbon number 1, carbon number 2, carbon number 3, 4 and 5, right? So this is how we can draw the bond line structure for the given complete structure. Okay, just observe this structure as well, guys. And then I'll write down the next one. So this is the structure. We are going to convert it to the bond line. Every corner is a carbon atom. So you can see here. And at this position chlorine is attached. So apart from carbon and hydrogen, all other atoms, heteroatoms, are written directly. Okay, we are not going to use the corners just like we use for the carbon. We have to mention, or we have to draw the chlorine, bromine, iodine, nitrogen, oxygen, etc. All other atoms apart from carbon and hydrogen we are going to actually mention in the formula. Okay, so these two examples you can just take a screenshot of these two pages. First of all, this one. And then this one. Okay, I hope you have taken the screenshot. Now that's all for the two-dimensional structural representation of organic compounds. Now after this, the next part is the structural representation of three-dimensional organic compounds, right? Now three-dimensional compounds we'll discuss some other day, and today we will stop here only. If you have any doubts, please let me know. You can write down your doubts in the chat box. I will be able to see the questions in the chat box, and I'll explain them in detail. Okay, thank you so much, guys. Before ending the class, let me just explain about DPP to you in just 2 minutes in short. DPP is daily practice problems. So whatever we are learning in a day for that particular session, we have prepared some question based on this. These are the interesting and easy questions only. So you will like to solve them. You have to solve. Okay, first of all I'll show you how it looks. So this is a student's portal actually. Similar will be your portal also. So this is, in this you have to go to resources, then to writing material, in which you will see DPP. If you click on this, you will be able to download it here, and you can solve all these questions on a blank paper or anything, notebook also, and you can just take a picture of it and upload it here. I will be solving them later on. I'll tell you the suggestions or the question based on this, corrections about it in the portal. So that's all for today, guys. Thank you so much, students, for your precious time, and please keep solving the daily practice problems. It is for you only. It is for your practice only. So if you solve them on a regular basis, it will be really very helpful for you to understand the concepts. Thank you so much, and all the best to you. Bye.